two of the biggest factors here around ad download performance is one thing that we can't change. And there's one thing here, no matter how great an engineer I think I am, that I can't fix, and that's the speed of light. Right? And the speed of light is how long it takes for that packet to go from me to the server in the UK and back, that ping time. I can't do anything about that. That's going to influence the download behavior. It certainly is. The other part of that that's really critical is how that content, whether it's the ad selection request or whether it's the ad creative itself or the various JavaScripts and plumbing and wiring that makes it all happen, makes the magic happen, gets packaged up for delivery over the network, right? Packets, right? Packets flying all over the place right now, all of you on wireless. Well, those are the two biggest determiners of what a web page performance is going to be, and an ad, by extension, is just a piece of web content. There are many, many other factors, and Pramod alluded to a lot of those. I mean, look at the best practices. They can tell you about very fine-grained optimizations. Use YSlow to target your ads and figure out, where can I make things better? Yes, there's a lot of things there. There's browser behavior. There's the way the publisher page is laid out. Yes, those all influence, but a major factor here is the geographic latency and the number of packets that get downloaded. Now, based on that, I've been modifying an existing analysis tool called Visual Round Trip Analyzer that's freely available from Microsoft Developers Network today, without the ad functionality, but it's still there to do web page optimization. It was developed by the Global Foundation Services team, and they've graciously allowed me to play around with their source code a bit, along with a fellow also in the Microsoft Ad Platform team. June Lee's been helping me out. And what we've been doing is we've been modifying Visual Round Trip Analyzer to score ads for performance. This really just becomes a count of we'll call it a critical path of packets that go through from the start of the ad to the end. Complementary to this, Microsoft Research has some network modeling tools that happen to take those two things as inputs and will predict, based on geographic latency and the number of packets, what the ad download time will be. It turns out a lot of network effects, slow start, TCP things that you don't necessarily need to know too much about when you're surfing the web, but make it all happen. Window size negotiation, they all turn out to be a function of the geographic latency and the number of packets. So we can really effectively and accurately model the behavior based on these two inputs. So how does it all work? Well, you download an ad in isolation, you capture the network traffic, you count the packets. I make it sound really simple. It's a little bit more complicated than that in terms of the nuts and bolts, but that's really it. There are other things that can potentially influence the download times, like the browser behavior and how it decides to request one thing or another in parallel. But I'm going to say that I'm not entirely sure at this stage how much that is an influence, but it's something we're going to look into more. But certainly from the standpoint of scoring, it's very independent of platforms because we're just looking at the network traffic. It's also very independent of the ad network. You can do this before it's even been sent or submitted anywhere. It can happen very early in the life cycle of the ad. So right now, when you look at your ad performance, you're typically going to measure it in a production environment. Well, if there's a problem with ad performance, it's very late then, and it's very painful and very traumatic to go back and fix or optimize those problems. So by utilizing this scoring approach, we should be able to catch performance issues far sooner and be able to take advantage of the fact that you can fix them before they become a problem for your end users and before they reduce the satisfaction of the advertiser. Now, here's a typical publisher page from the MSN homepage. It's very rich with content, right? In fact, teasing out the ads from this content is tremendously challenging once it's been published. If you were to profile this and look at a time series graph, there'd be a million things going on. And your browser handles that, and that's all fine. But if we want to understand how the role the ads play, I guess I jumped ahead a little bit. This would be the banner ad up in the far right corner. Very simple. There's an ad selection request in red that happens on one port, and then the downloading of the content image on another, which is in blue. We can score that by counting the number of packets, and then we can run it through our Microsoft Research approved algorithm to tell us what the estimated download time would be. These are some estimates based on general round trip times that you would experience as a domestic user, or maybe someone in the UK might experience a far slower ad. But you can see as you go further and further away from your ad network and your CDN, that's hosting the ad content, the ad experience for this very same ad will take this one could take up to 1.5 seconds to download if you're very far away. If we look at a more complex ad, like the flash ad that just got covered over, you can see that there's some things that happen in parallel. That tan-colored line there in the time series graph is just the JavaScript being loaded. So the score takes this into account by counting the packets along what we're calling the critical path. There are more packets in this case, and the overall estimates for the download time go up. And again, this is entirely predictive. This packet counting is a model for the ad performance. Obviously, as part of the working group, we need to investigate this because I've got a list of some questions and open issues we're trying to track down about how the algorithm works. But by having this tool, we're able to actually score ads based on the network traffic that we've captured.